I'm live, I guess. Okay. Let's start by just opening the problem statement. Yeah. So uh, let's just understand the problem first of all. Equalize the towers. You can see I haven't solved this question till now. I'm opening this problem statement for the first time. I think like the screen is visible or not. Let me just see it. Yeah, the screen is visible, right? So let's start by just reading the question. You are given an array heights representing the heights of towers and another array cost where each element represents the cost of modifying the heights of respective tower. Okay, I'll have two different arrays. Okay, the goal is to make all towers of same height by either adding or removing blocks from each tower. Okay, I can either add or remove a block from each tower. Okay, modifying the heights of tower, like adding or removing by 1 unit cost of I. Okay, the cost is mapped with the like heights of I. Okay, okay, just let's just understand with the help of examples. The heights can be equalized by either removing one block from three and adding one in one, or adding two blocks in one and adding one in two. Okay, since cost of operation in tower 3 is 1000, the first process would yield 1010 while the second one yields 120. Okay, okay, I think I understood the problem statement. Let's just try with a few more examples. So the first one is 1 comma 2 comma 3. Okay, and the cost is 10 comma 100 comma 1000, right? So for the first one, let's suppose we are just making all the buildings or all the heights of, let's suppose it's 1 2 3. We'll just equalize all the heights, and we can equalize all the heights by three ways. Keep doing all the heights, making all the heights as 1 comma 1 comma 1, doing all the heights as making all the heights as 2 comma 2 comma 2, and the third one as 3 comma 3 comma 3, right? So these are the three possibilities that we can make our heights array. And the cost to make this is going to be, so the first one is going to be exactly same. So here we don't have to take any cost. Second one is 2. Okay, so we are incrementing, we are decreasing one by one. So it is going to be 100. Here we are, what we are doing is we are just decreasing by 2 units. So it is going to be 2 into 1000, which is going to be 2000. So the final cost will be 2100, right? So same goes for this case. So we are incrementing the first one by 1 unit, so it is going to be 10. We are not incrementing the second unit because it is going to be the same, so 0 for this. And for the third one, we are decreasing one, so it is going to be 1000 because we are decreasing it by 1 unit. So the cost will be, in this case, 1010. Okay, the last one, we can see that we are incrementing the first one by 2 units. So it is going to be 10 into 2, which is 20 units. The second one, we are incrementing it by 1 unit, which is going to be 100. And the third one, we are not incrementing it because the height of the third one is exactly 3. So it is going to be 0 unit, right? So the cost will be 120, just 120. The minimum of these three is 120. I think this is the problem statement, like basic problem statement of this question. Okay, so talking about the edge cases, first of all, okay, the minimum height is going to be 111. Okay, minimum cost. What if the cost is going to be the same? So we'll just have to compute the like the minimum one, and we'll just like update the values according to that only. Okay. What if uh, we'll have the heights that is going to be of same length? What is going to be the output in that case? Suppose we have something like uh, 3 comma 3 comma 3. So in this case the output is going to be 0, right? Because we are not using any operation. Okay. Okay, the brute force approach that comes in my mind is what we can do. We can just do one operation. We can uh, iterate through all the elements in the array. Okay, like you can see it as 1 2 3. So we'll just like okay, we'll just do this dry run. Okay, and sorry, brute force approaches. We'll just update all the elements of the array, or we'll just check for all the possibilities, like changing it to 1, changing it to 2, changing it to 3, and getting the cost after doing all these things, and the minimum is going to be our answer. How we are going to do this? We can run a loop from we can do two loops, like we can do like uh, we can run iterative loops, not iterative loops. You can use optimized solution is going to be using prefix sum, but in this case we can use nested loops, and we can just keep track of all the costs that we are going to get. Let's just understand this approach in more detail. Suppose I have something like the finalized, we have to return it in, right? Finalized answer, or finalized minimum cost, we can say. Minimum cost is equal to, let's suppose we have it as int max, because we have to minimize it, and the size will be, size is equal to cost dot length or height dot length. That is not going to make any difference because both of them have same length. Okay, starting from the first element for index is equal to 0 to index is smaller than size, index plus plus. Yeah, what we can do is we can simply keep track of all the cost that we are going to get by making this particular element into the desired element. Let's just code it, and I'll explain you in detail. Int cost, uh, cost of making, or cost of updating, update updating is equal to 0. Let's suppose it is 0 for now, and we'll run again a loop where the second index will again start from 0, and the second index is going to go to till size of the array, and second index plus, right? So what we'll do is we'll just keep track of the cost of updating is equal plus is equal to, we'll just add it by what, the cost of second index into the absolute difference of the both the indices, like the index of height of uh, second index minus height, heights of first index. Okay, we can do this. let me just explain what I did here. Just okay. Let me just explain what I did here. Uh, what I have to do is I have to get the cost of updating. Okay, so let's suppose I have to just make this. I have this array as 1 2 3, and I have to make this 1 1 2 3. Okay, so how many units I have to add? So I have to add 2 units. So 3 minus 1 is equal to, we are going to get 2. Here you can see heights of second index minus heights of first index. And also what cost we have to just add to, like add 2 units from the first element. So we have this mapping as 10. So 10 into 2, 10 into 2, that's it. This is what we are going to have. So after this, we'll just after running all this loop, we'll just check the minimum cost is equal to minimum minimum cost comma the cost of updating. We'll just do this, and yeah, this is our code. So like yeah, it is going to be end here. Cost of updating plus is equal to cost of second index into absolute of heights. Mm, Second index, first index, it is going to be index, right? Index, okay. Index, second index plus plus, okay. Yeah, I think this will work fine if I'll not get a TLE, I guess. Let's just run this code and see. Do I have some compilation error? Yeah. Int max, minimum cost, length. Okay, size now. Size and int max. Let's just keep it as -1. Okay. So minimum cost is not going to be greater than -1. Or mm, yeah, let's just keep it a -1. Okay, your acha int max now. Minimum cost that we are going to get is, let's keep it as int max. Why it is not working int max, or 1e12 or anything like that? We can do that. This is not working. Yeah, it is working fine. Int max, right? So let's just submit the code. If I'll not get a TLE, this is the brute force approach that I think this should work. Okay, wrong answer. Your output is -2 and this that output. Okay, okay. Like this is getting out of bounds because in like this is going to be end, right? So if we use long, it will work fine. Or we can do one thing. We can just we can just keep a condition here, like if uh, cost of updating is greater than or equal to 0, then only update this minimum cost. Okay, yeah, I think now this will not give a wrong output because it is getting out of bounds, right? So let's just run this code. Yeah, it is working fine. Let's upload this solution. Okay. Yeah, so now we are getting our TLE, right? Because yeah, the time complexity of this solution is close to, I guess, big O of n square. No, not close to it. It is big O of n square, and the space complexity is big O of one, but the time complexity is way bigger, so it is not going to work. Can we think of another solution to solve this question? Let's just think about that. Okay, heights of this 1, 2, 3. Cost is going to be 10, 100, and 1000. Removing that from 3 and adding. We are just removing and adding elements. We do something like fix some or just sort five, seven. Okay, we just find the median height, right? Median height. Find the median height. One, two, three. 250. Okay. Let's suppose it is 51, 2, and 3. The cost is 10, 100, and it is 50, right? So what I would have done, I would have just like updated it as 2 fun. Okay, I think this will work. Let's just think of what we can do. Yeah, we can do one thing is we can just keep the cost and the heights in a pair of pair of vectors and vector of pairs, and we'll just check the main thing is we have to find for which height we have to equalize. Like in this question, as you can see, it was 1, 2, 3, and based on the cost of all the heights, we have decided that the equalization should be done around 3. Okay, and in this case, we decided that equalization should be going to done like around the element 1 or heights 1. So what if the question was something like 1, 2, 1, 2, 3, and the cost of updating the array was or heights was 1, 10, 150. Let's suppose this. So what we could have done is we can just update chosen the index or the heights too, and we could have equalized all the index or all the heights to 2, right? So the updated array or updated height should be 2 comma 2 comma 3, and the cost that we would have got is 10 comma 0 comma 50, which is going to be 60. Total cost is going to be 60, which is going to be minimum, right? So yeah, this is going to be our answer. But the main thing is how we are going to find the median or the like around which index, around which height we have to just update or equalize all the heights. That's the main thing. You can keep something as 10, 1110 plus 1, which is going to be 5, 5 again, 555. Okay, or you can say 160 divided by 2, 160 divided by 2, which is 60, which is 60, 80, 80, okay. Okay. Okay, let's just understand the idea that I have in my mind. What I can do is, I'll just, first of all, I'll just have all the sum of the costs. Like in this case, let's understand this case only. Okay, in this case, what is the cost of all the elements? Let's remove this. Let's understand this. The summation of cost, summation of all the cost is equal to 160, right? So if we'll just check at which index we have to just equalize all the heights. So what we can do is we can just uh, divide the sum of all costs by 2 plus 1 divided by 2, which is this is what we use to get the equalization of all the costs, divide by 2. And if it is greater than the like previous sums, you can say the previous sum, like 10 plus 100, if it is greater, then we have to equalize around this index only. If we are not understanding by this example, let's take another example. Let's take this example and let's understand this. Okay, so what is the sum of all costs? Sum of all costs is equal to nothing but 1110. So what is going to be the value of sum of all costs plus 1 divided by 2? It is going to be around 555. Okay, so after this, around which index this value is going to be like increased, or this value is going to be greater than. Let's suppose let's add this, the first element. It is going to be 10. 10 plus 100 is 110. And after that, when we'll add 100, we when 1000, we can see that it exceeds this limit, right? So it is exceeding this limit, so we have to equalize all the heights around this element only. Okay. Okay, let's just try to code this solution. It is going to be more clear with this coding part. What I can do is I can keep why I'm keeping a pair of int comma int. It is because keeping the pair, like in the future, or in the like upcoming coding part, when we'll just know which around which index we have to equalize all the heights, we just have to take all the elements and and see how much difference we have to just add to equalize all the elements, right? So I'll keep a pair of int comma int, which is going to be the height cost. Okay, I'll just add for int I is index is equal to 0, index is smaller than size, index plus plus height cost pushback heights of I comma vector of pushback heights of I comma cost of I. Okay. Okay. Now getting the sum of all, like int sum uh, cost sum is equal to, first it is going to be 0, Now I'll just add all the sum for uh, auto x height cost. I'll just add cost sum plus is equal to x dot second. Okay. Mhm. Now, now I have to just find the index, right? So what I'll do is uh, I'll just have to find the median weight, right? Okay. Let's keep another variable and median sum is equal to 0. Starting from the first index, we'll just keep adding all the elements. For int I is equal to 0, I is smaller than index is equal to 0, index is smaller than the size index plus plus, right? Okay. Median sum is plus is equal to uh, height cost of index dot second. We could have done that. No, what we could have done is for auto x or auto element of height cost, we'll just add median sum plus is equal to element dot second. Okay. If median sum is greater than our cost sum plus 1 to like just to make sure it is never going to go out of bounds, cost sum plus 1 divided by 2. If this is the case, what we'll do, I'll just keep the like equalized height is equal to -1. Here it is -1. I just keep the equalized height as equal to. Okay. So this is what I will do now. Till here I'll just get the equalized height index. Okay, like if it is in this case, let's suppose in this case it is 2, so I'll get 2 here, and if in this case it is 3, I'll get 3 here. In this case I'll get 1 here. Yeah. So now adding all the elements in the answer, right? So what I'll do is I use the same method or same approach that I did last approach into first approach. What I'll do is I'll just for an auto element height cost. Okay, I'll just add the sum. Let's keep in final answer or the minimum cost. Minimum cost is equal to, it is going to be 0. It is not going to make any difference. So what I I'll do is minimum cost plus is equal to the cost, the equalized height, absolute of equalized height, equalized height minus the first element dot first, the first index into the cost of making. So the element second. Yeah, yeah. Let's just see everything is working fine. Let's try run this code, comment it out. Okay, vector pair height and cost, and index is equal to 0. I just push back height and cost. Okay, and cost sum is equal to 0 for auto x height cost sum plus is equal to x dot second. Added all the cost. Okay, in medium sum equalized height is equal to -1 for auto element height. Medium plus is equal to, okay, medium sum is greater than cost plus 1 divided by 2. Equalized height is equal to element of first. Minimum cost is equal to 0 for auto element height cost. So it's going to be the same. Yeah. Am I getting any compilation errors? Yeah. Yeah, index. Here it is going to be index, right? Anywhere else I'm getting a compilation error. Yeah, okay. Size was not declared, okay. And size is equal to cost dot size. Okay. Overload function. Um, okay. Alright. This is going to be like this. Yeah. Yeah. So this is working fine, I guess. So yeah. Let's just submit this code and see if it is working fine or not. Wrong answer. Hmm. Okay. Let's just see where it is not working. 465523. 465523. What is the sum? 5, 6, 7, 8, 9, 10. 10. Okay. From 4, what I'll do is let's just update it. 5, 5, 10 by 5, 5. So I have to equalize at 4, right? Equalize at 4. Okay. And uh, medium sum is okay. Medium sum is greater than or equal to, bro. It is going to be equal to. Let's check now. 243 546. 243 546. 6 foot and 5 15. And here it is. Just do this 15 by 2. So 4. Right? 4 I have to just date. Mm, mm, I'm getting error. So this is equal to this. Okay. Yeah, it should work fine. Absolute of equalized height minus element of first. Equalized height minus element of first. Okay. Into tower of second. Yeah, it was working fine, bro. Where I'm getting an error. Mm, okay, what I can do is um, for all the elements that I have been okay. What I can do is I can before like this I can just sort the whole array. Sort height cost dot begin comma height cost dot end. I can do this. Now I'll just compile and run. Realized height is equal to minimum first. Minimum cost is equal to 0. So we go into element of second. Yeah, this will work fine, I guess. Yeah. So this worked fine. See, at the last, why I did this, so like I sorted all the heights because I'm starting from the very first index. Okay, so I have to see for which minimum height I can equalize all the heights. That is why I just use sorting height and like height cost dot begin height cost dot end. It will give me the heights in sorted order, and yeah, this will work fine. This is the solution with you can say mm, like keeping the heights and cost of each element. It is somehow like a brute force and just the optimized solution. It is also not the optimized solution because like you can also in place of keeping the array you can use binary search where you can just keep because the main thing is finding this median array median element or equalized element, right? So you can do something like a binary search and starting from the first index and going to the last index you can just yeah, you can just compute which element we have to like from by which element we have to compute or we have to equalize. That will give you the correct solution. So that's all.